Hello, and thank you for watching this webinar on doing statistics with the NumWorks graphing calculator. My name is Nick Koperstein, and I'm a math teacher in residence at NumWorks. I'm very excited to dig into all the statistical features of the calculator and work through a few problems with you. During this webinar, I'll be using our free online emulator, so you can follow along with either your handheld calculator if you've updated it recently, or otherwise I would encourage you to use our emulator or mobile app, as these are always up to date with our latest version. There are three applications on the calculator that directly relate to statistics. The statistics application allows you to study one variable datasets with graphical displays and summary statistics. To analyze the relationship between two quantitative variables, we'll use the regression application. With this application, you can display a scatter plot, measure the linear association with correlation, and determine the equation of the regression model. And the inference application houses your probability distributions, as well as hypothesis testing and confidence intervals. Today we're going to start with the statistics application. So what I'll do is click OK to open the application, and here we see that we do have three tabs at the top. We have the Data tab, the Graph tab, and the Stats tab. The first tab is where we will enter our data. You can see here that we can enter up to 3 data sets. For each data set, you have 2 columns, a value column and a frequency column. So a list to enter the values and a list to enter how many times those values appeared in your data set. So we can start with an example here. We'll pretend that we do have some quiz grades. So in the first column, I'm going to enter our values, in this case our quiz grades, and in the second column, I will indicate the frequency of those grades, the number of students with a specific grade. So my lowest grade was a 60. I don't have to put them in order, but I've already got my data in order, so I'm going to start with my score of 60. Notice that it automatically gave me a frequency of 1. I did have 2 students with a 75, so I could type 75 in twice, or update my frequency to 2. Then I had 81. I had 3 students with an 81. I had 4 students with an 89. I had 2 students with a 92. And then 2 students with a 95. Once again, you don't have to enter the values in order. We do actually have an option to come up here and click OK on our column header, and that would allow us to sort it if we would like to. What I'd like to do now is take a look at the different graphical displays that I can see for my data. So what I'll do is I'll navigate up to my tabs and over to the Graph tab. Here when I click OK, we'll see that we have 4 options to select from. We can plot this as a histogram, a box plot, a cumulative frequency plot, or a normal probability plot. We'll take a look first at the histogram by clicking OK. And we do notice that at the bottom banner here, we see the interval as well as the frequency and the relative frequency. Right now, my first bin is highlighted yellow, and I can use my left and right arrow keys to move into those different bins. And as I do, that banner will adjust. We can also change the settings of this histogram. We can go from the default view here up to the settings to change the bin width and the starting value. So if I wanted to change this to maybe letter grade, so a 10-point scale, I could change that bin width to 10. I'll keep my X start at 60 and click confirm. And now I've reorganized my data into letter grade. So from 60 up to 70, 70 to 80, 80 to 90, 90 to 100. If we want to change the type of graph, we will navigate back up to the Type button here and click OK. And this is where we could switch from a histogram to, let's say, a box plot. So if I click OK on box plot, you will notice that we do see a box plot with our x-axis given to us. We do have an outlier indicated here, so our minimum is an outlier. We can once again use my left and right arrow keys. You'll notice that as we navigate through the data set, through the graphical display, we are seeing the 5-number summary on the bottom banner. So we have our first quartile, our median, our third quartile, and our maximum. Now, depending on your course, you may not be using outliers or displaying them. So back up in your settings for a box plot, you can toggle on or off the option to display those outliers. Now let's go back up to our type one more time, take a quick look at these other options. Again, we can do a cumulative frequency. We can also do a normal probability plot to assess normality. So depending on what course you're taking or teaching, you might find these different graphical displays relevant and helpful. What I want to do now, though, is navigate back up to my tabs and select the Stats tab. This is where we're going to see summary statistics for our data set. And it is going to include both the vocabulary word as well as the symbol here. So I can see first my 5-number summary, and then I'm giving some information about its mean and its standard deviation, as well as if this were a sample, I can find its sample mean, sample standard deviation, sample variance. So I think seeing both that symbol and vocabulary word can be really helpful for students. What I want to do now, though, is return to the Data tab. So I'm going to do a quick shortcut. If I click this back arrow, that will jump me back up to those top tabs so I can switch over to the Data tab. And what I want to do is take a look at some of those other options for a data set. So once again, if I navigate up to either of these column headers and click OK, we find our column options. This is what allows us to sort our data. We can also fill with a formula. This quick option right here, show in graph and stats, turning that on or off will determine if the graph and the statistics are viewable. So that's a great way to hide a data set without having to delete it. But what I want to do is take a look at the cumulative frequencies. If I turn that value on, that's going to add a column here for my cumulative frequencies. So summing up the values of the frequencies at or below the current value. We can also compare data sets and distributions very easily on the calculator with the statistics application. What I'm going to do now is actually add a second data set. So I'm going to go over to V2N2, and I'm going to demonstrate using a formula as well. So what I want to do is I want to take my quiz grades that were in V1, and I'm going to give everybody 5 points back. So instead of doing this manually, I'm going to create a formula that takes the values of V1 and adds 5. So I'll navigate up and click OK on V2 to open up its column options, and then select Fill with a Formula. We do have a few options here, some templates that we can use. So we have an empty template where we can type pretty much any formula that we'd like, but there are some templates that just give you a head start. For example, if we wanted to fill this column with the integers from 1 to 10, where I can adjust that value of 10. If we want to have 10 random values between 0 and 1, if we want to take the outputs of L of k, where k goes from 1 to 10, each of these functions in the curly braces, the curly brackets, those are editable. So I could also do like sine of k or rand int of k. So all those are possible. And then just to demonstrate, you can also, of course, add values from different lists. So for example, here I actually want to take v1 plus 5. So I could use this to start. I could grab this and then just adjust it. So I want to take the values of v1 and I want to add 5. So I will click OK. That is going to just take all the values of v1 and add 5. Now here, notice I also need to adjust my frequencies. I need n2 to equal n1. So once again, I'm going to open up its column options, select Fill with a Formula. I'll just use the empty template this time, and I want this to be n1, n2 equals n1. I can take advantage of my alpha key, my shift alpha, to do capital N. But if we go into our var menu, that's going to give us everything that's already saved in our calculator, including our lists, and our list will include everything from the stats and the regression applications. So I want to take n2 and set it equal to n1, and that's going to update my list for me. Now, when 2 or more data sets are selected, you can view both of those at the same time in your Graph tab. So if I head back to my Graph tab and I select, let's maybe change this to a box plot, and I'll turn my outliers back on, we can very quickly see how that change affected my distribution. So here we just added 5, so we just see a shift in my distribution. But we can easily compare those data sets, those distributions, as well as their summary statistics. One last thing on the Data tab, we can also very quickly clear a column or a data set. So instead of turning them off, if we want to just hide them once again, we could just toggle off Show in Graph and Stats. You can see this is grayed out. when I go back to my graph, it's only going to show one of those displays. But if I want to completely erase a column or erase a data set, I can either come up here and click OK, and I can reset the frequencies. That's going to reset all the values to 1. Or if I do it to the value column, it's actually going to clear the entire table. So do make sure that that's something you want to do before you erase that. Also, just a shortcut, you can, of course, just hit the clear button. So if you hit the clear button or the backspace button on the column header, it'll act the same way. So since I did that on V2, it is going to erase the entire table. All right, at this point, we're going to head back to the home screen using the home button and take a look at the regression application. So as I mentioned, the regression application is great for analyzing relationships between two quantitative variables. We're going to be able to display some scatter plots. We can plot different regression models, view a residual plot, and even make predictions. So just like with the statistics application, you'll notice we do have 3 tabs at the top of the screen here. We've got the data tab, the graph tab, and the stats tab. And once again, we do have the ability to add up to 3 data sets. In this case, because it's going to be 2 quantitative variables, we have the columns x1, y1, x2, y2, and x3, y3. We're going to take advantage of this first data set, x1 and y1, and enter some values. Feel free to enter these with me. So we've got for x 15, 16, 17, 21, 25, 32, and 33. And 36. Now we'll head back up to the top of the y1 column and we'll add our y values. So for the y values, we have 75, 72, and I am just hitting this execute key, this enter key at the end of each value to skip down to the next row. So 74, 64, 62, 50, 53, and 43. Once your data set is complete, we can head up to the Graph tab to take a look at our scatter plot. So we'll click OK on Graph, and right away we do see our scatter plot. We can use our left and right arrow keys to navigate through the data set. You'll notice on the bottom banner that we have our X and our Y values. Now what I want to do is I want to add a regression model onto this data set. A couple ways we could do that is we could navigate up to this regression menu, but if we are on a data point and we simply click the OK button, that will open up our regression menu, and the first thing we need to do is select a regression model. So for this problem, I'm going to select just a linear regression by clicking OK, and it will automatically display that linear model. It'll also highlight the mean point, x bar and y bar, demonstrating that that regression model does go through the average of x and the average of y. I can still use my left and right arrow keys to navigate through the data set, but I can also navigate onto the regression model. So currently I am above my model, so if I use my down arrow to navigate down to the regression model, you'll see that I now have in my bottom banner x, the predicted y value, y hat, as well as the equation of the regression line. I can also find this information in that regression menu. So once again, I can navigate up to the top to get to that regression menu and click OK. This is where I can change the model type from linear to another type. I can also view that regression equation. I could take advantage of my copy from Shift Copy and Paste if I wanted to graph this, say like in the Grapher application. I can also view my R-squared value, my coefficient of determination. If I'm looking for R, my correlation coefficient, that will be in our Stats tab. We'll take a look at that in just a moment. We can also very quickly find a residual plot. We can plot the residual plot. This is really nice. You just simply click OK, and it will give you a residual plot. So it'll give you the X values and the residuals of each of those X values. So the difference between the observed and the predicted values. Use my back arrow to back out of that. I can also make predictions. So I can either predict the value of y given an x value, or I could determine which value of x is needed to output a given predicted y value. We can also remove the regression, which would just go back to the scatter plot view. I'm going to use the back arrow and actually just go ahead and take a look at my stats tab. So once again, the stats tab is going to give you some summary statistics here, both the vocabulary word and the symbol. And if we navigate all the way down, we will find, for example, the R value, the correlation coefficient, and we can see its value. We'll now head back to the main menu using the home button, and we're going to go ahead and take a look at the inference application. So this is the last statistics-themed application. The inference application actually contains 3 different sections. You've got your probability distributions, your hypothesis testing, and constructing confidence intervals. And we're going to start by looking at probability to take a look at some probability distributions. So by clicking OK, we'll take a look at all the different probability distributions that are available. This should cover everything you would need in the high school curriculum and beyond. We have both discrete and continuous probability distributions. What I want to do is take a look at the binomial distribution. So once we click OK on any distribution, we'll be asked to define our relevant parameters. So for the binomial distribution, that's going to include your number of trials and your probability of success. And I'm actually just going to keep the default values here. For some context, we will assume that we are flipping 20 coins and there's a 50% chance of success, and we'll call that getting a heads. So I'll go down and click next, and now we can see that we are given a visual of our binomial distribution, as well as at the top there a probability statement. So what I want to do here is, let's say, determine the probability that no more than 8 coins are heads. So that is, I want to find the probability that x is less than or equal to 8. So we can see that I've already got that inequality here, and that my cursor is currently at the spot where I type in that value, 0. So I'm just going to type in an 8 to change this to x less than or equal to 8 and click OK. And you'll see that we have our probability automatically displayed, so 0.2517, as well as that corresponding area under the curve. If I wanted to adjust this statement, so maybe I wanted to find the probability that it is greater than a value or between 2 values, what I need to do is change the area using this drop-down box here on the left. So I'm going to use my left arrow key and click OK, and this is where I can change the direction of that inequality. I can also find the probability that x equals exactly a value. So we'll say that the probability that x is between, let's say, 2 and 6, and that's going to give us that probability there. And again, we could also find the probability that x equals a value. So maybe we want to find the probability that x equals 9. So each of our distributions is going to work in a similar fashion. So I'm going to use my back arrow key to back out of my binomial distribution. And let's just take a look at a normal distribution. Once again, we are asked to input some parameters here. So in this case, it's our mean and our standard deviation. So we'll do a mean of 128 and a standard deviation of 12. Once again, I'm seeing my normal distribution, this time in a probability statement. It's going to work in the same way, so I can find the probability that x is less than or equal to, for example, 120. But we can also work backwards. We can do our inverse operations in this same application. So if instead I wanted to find the value of x that is at the 90th percentile, that is at 90% of the areas to the left, what I'm going to do is actually navigate over to the probability field and type in 90%, that is 0.9. And that will update my x value and my display to give me that 90th percentile. So x would be 143.3786. So I'm going to back out. We're going to take a look at another section here. We're going to take a look at hypothesis testing. So with hypothesis testing, we can do hypothesis tests for means and proportions, as well as chi-squared test and tests for the slope. Each of these is going to work in a similar fashion. So for example, if I open up a one proportion z-test and click OK, we're going to be first asked for our hypotheses. So we need to enter a null hypothesis as well as an alternative hypothesis. So here on the null hypothesis, I can adjust the value of the null hypothesis, the value of p. And then for the alternative hypothesis, I can adjust the direction. So currently it is that p is greater than 0.08. If If I click OK, I can see I could have selected less than or not equal to. So I could do a two-tailed test here. I'm going to leave my default values in right now and go ahead and click Next. Now I'm asked for the number of successes and the sample size. So I've already got in some values here, 47 and 500. And then I can also input a significance level. Once I click Next, I'm going to get all of my calculated values. This is really all the information I need to answer my question. I've got my sample proportion, p hat. I've also got my z-test statistic, and then the p-value. But what's really nice is if I actually move to the next screen, I'm going to see a display of my normal distribution with that test statistic marked and the p-value shaded there. But we also, because we inputted at alpha, the significance level, we can see that rejection region. So we can see where this test statistic and the p-value and how they are related to alpha. So in this case, my test statistic is not within that rejection region, so I can visibly see that I'm going to not reject my null hypothesis. We can also, in case those values are very close to each other, we can use our plus and minus key to zoom in, which might just help us see where our test statistic is relative to that rejection region. So each of our tests is going to work in a similar fashion. One thing I do want to mention is if we're doing a test for a mean, you may be interested in using the data that you've entered in the stats tab. Now or the stats application. I've already cleared out my stats application information, but one thing I do want to mention is once we select a test and you select your hypotheses just like before, we don't currently offer a way to directly pull from the data set, but you can, of course, go to the stats tab of the statistics application to find those values, but you can also take advantage of our list operations. So if I, while I'm in mean, go into my toolbox, I can actually select down here from lists. I can say that I want to find from statistics, the mean of a list. And if we had values in our statistics application, in V1 and N1, they would show up just like they are here for X1 and Y1. So I could actually find the mean of X1, and I can even input a frequency. If I put a comma here and do my other list, let's say this was V1 and N1, then that's going to find the mean, the weighted mean. So it's going to take the values of V1 with their frequencies N1 and compute that mean for me. So that would work. I'm not going to do that for this because those are just for my regression application. And I could do the same thing with my standard deviation. So back in my toolbox where I selected mean, I could also do the sample standard deviation. So that's a nice way to use data that you've already entered in the statistics application in the inference application without having to copy down values and retype them in. I'm going to actually back out of this. This one's going to work in the same way. I want to mention, though, that with the slopes, this will automatically grab the values from your regression application. So you can automatically use the X and the Y values from the regression application. You could also delete these if you wanted to and clear that column and type in different values if you needed to. The last thing I want to look at before we just look at some example problems doing some confidence intervals and hypothesis test is just the confidence interval section, just to get an idea of what this section looks like. It's going to work in a very similar way to our test, where we're going to select the type of test we want to do, or the type of interval that we want to do. So a 1 proportion, a 1 mean, 2 proportions, 2 means, or a slope. I'll take again a look at the 1 proportion z interval. We are asked for the number of successes and the sample size, as well as your confidence level. We are given those calculated values, so I've got my sample proportion, I've got my critical value, my standard error, and my margin of error. And then on this last screen, we have a really nice visual here where we can see our confidence interval, both written as the point estimate plus or minus the margin of error there at the very bottom. And we can also see the endpoints of that interval on this number line. And here we can be reminded this is a 95% confidence interval. We can also get a nice visual of, well, what would have happened with different confidence intervals or confidence levels. So if I was 90% confident versus 98% confident, This is a static screen. That means we are not able to move up and down to those different intervals. That's actually just in case you accidentally clicked up or down. You might start copying down values for the 90% confidence interval when you didn't mean to. So if you do want to change that level, that confidence level, just back out a few times, make that adjustment as needed, and you'll very quickly be able to find the new confidence interval. What I'd like to do now is go ahead and turn our attention to a few former AP statistics problems so we can see the calculator in action. Here we have the 2018 AP Stats Free Response question number 4 that states that the ACL is one of the ligaments that helps stabilize the knee. Surgery is often recommended if the ACL is completely torn and that the recovery time from the surgery can be lengthy. A medical center developed a new surgical procedure designed to reduce the average recovery time from the surgery. To test the effectiveness of this new procedure, a study was conducted in which 210 patients needing surgery to repair a torn ACL were randomly assigned to either receive the standard procedure or the new procedure. What I want to do is jump to question 4, which provides the summary statistics on the recovery times from the surgery and asks if the data provide convincing statistical evidence that those who receive the new procedure will have less recovery time from the surgery on average than those who receive the standard surgery for patients similar to those in the study. So in part B, we're asked to perform a significance test. So long as our conditions are met, we will perform a 2-sample t-test for the difference in means. From our list of tests, we'll select 2 means. Since we don't know the population standard deviation, we're going to use a t-test. Now our null hypothesis is that there is no difference, that is, the difference is 0, and our alternative hypothesis is that the new procedure has less recovery time. So I'm going to let mu1 be the average of the standard recovery time, mu2 be the new one, so mu1 minus mu2 will be greater than 0. Now we enter our relevant statistics. Using the table from the problem, the sample 1 mean was 217, its standard deviation was 34, and its sample size was 110. For the sample of the new procedure, its sample mean was 186, its standard deviation was 29, and its sample size was 100. Since no significance level was given, we'll use 0.05. When we select Next, here we are given all of our calculated values. This includes the t-test statistic, the p-value, which is very small, and our degrees of freedom. On our final screen, we can again see all of those final values as well as our visual here. Now our t-test statistic is 7.127, which is going to be very far to the right, so far that we don't even see that on our graph, but we can see the t-value when we zoom in here. So we definitely can reject the null hypothesis in favor of our alternative hypothesis. Let's return to all of our tests and take a look at another question. Here we have a question from the 2017 exam. It says that the manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but instead fill the cup with a soft drink from the beverage fountain instead of filling it with water. The manager selected a random sample of 80 customers who asked for a water cup when placing an order and found that 23 of those customers filled the cup with a soft drink from the beverage fountain. For part A, we are asked to construct and interpret a 95% confidence interval for the proportion of all customers who, having asked for a water cup when placing an order, will fill the cup with a soft drink from the beverage fountain. Back on our calculator, what I'm going to do is enter our intervals section. And since we are only dealing with one sample, we'll do a 1 proportion z interval. Our number of successes, that is the number of customers who filled their cup with soda, was 23, and our sample size was 80. We were asked to do a 95% confidence interval, so we'll keep our confidence level at 0.95. On this screen, we're given our sample proportion, our z-star critical value, standard error, and the margin of error. But if we click on Next to see our final screen, here we can see our confidence interval is 0.1883 to 0.3867. So we are 95% confident that the true proportion of customers who would fill up a water cup with soda is between 0.1883 and 0.3867. Now if we look at Part B, it says that the manager estimates that each customer who asks for a water cup but fills it with a soft drink costs the restaurant 25 cents. Suppose that in the month of June, 3,000 customers ask for a water cup when placing an order. Use that confidence interval from Part A to give an interval estimate for the cost to the restaurant for the month of June from the customers who ask for a water cup but fill the cup with a soft drink. Well, since there are 3,000 customers, we can find the interval for the number of customers who fill a water cup with soda by simply multiplying the endpoints by 3,000. To do this, we can simply copy the interval by selecting Shift Copy. Copy is the shift option of var. That is going to copy the endpoints of that interval. We'll now click the home screen and open up our calculation application and paste that Shift toolbox. That's going to paste that interval, and we can then multiply those endpoints by 3,000. This provides us an interval for the number of customers who we believe will fill a water cup up with soda, but now we want to multiply this number by the cost per customer, which is 25 cents. So we'll multiply by 0.25 to get an interval estimate of $141.23 to $290.03. The final problem that I'd like to take a look at is from 2013. It says that the Behavioral Risk Factor Surveillance System is an ongoing health surveys system that tracks health conditions and risk behaviors in the United States. In one of their studies, a random sample of 8,866 adults answered the question, "Do you consume 5 or more servings of fruits and vegetables per day?" and that the data are summarized by response and by age group in the frequency table. We're asked once again, do the data provide convincing statistical evidence that there is an association between age group and whether or not a person consumes 5 or more servings of fruits and vegetables per day? Here we need to perform a chi-squared test for independence. So we're going to head back into our inference application, back out of my interval, move back into test, and head down to chi-square. From the chi-square menu, we are going to select a test for homogeneity/independence, and the first thing we need to do is fill in our table. Notice that we start with a 2x2 table, but this will automatically expand. So our table was yes and no for my columns and my age group for my rows. So in that first group, we had 231, that is 18 to 34, who said yes, 669 who said yes for 35 to 54, and 1,291 who said yes for my 55 and older. For those who said no, it was 741 for 18 to 34, 2,242 for my next age group, and 3,692 for my 55 and older who said no. Now the other options, these are all grayed out. I don't need to put anything for these last column and last row. Instead, I'm going to move down to next. Here we're going to see our expected values, which is often needed when checking our conditions. And we can also see our row and column totals. At the end of the test, if we need to check our contributions to the chi-squared statistic, we can click our Contributions tab to find those values. What I'm going to do is click Next to get all of my calculated values. Again, this includes my chi-squared test statistic, my p-value, and my degrees of freedom. And finally, I do have my chi-squared distribution. I've got my chi-squared test statistic of 8.983 and my p-value of 0.0112. I can see that that is definitely in my rejection region. And if I zoom in, I can get a nicer view of that so that I do know that once again, I can reject this null hypothesis in favor of the alternative hypothesis. Thank you so much for watching this webinar. If you have any questions about the statistics applications or any questions about NumWorks, feel free to reach out to me or to anyone at NumWorks, emailing contact@numworks.com. Thank you.